So, in connection with our last session, let's get started with the, overall sequence type or the list and, various part and parcel of it as far as Python goes. As we know, Python is basically has been created to make the AI more efficient, more, concise or more to the point type of programming, right? So for that, what we try to do, we try to improve our data types as well. So most of the data types are in line with the AI needs, in line with the uh, needs of machine learning and all those things, right? And we want, as we churn large amount of data, what we are trying to do here, we are trying to achieve the maximum throughput without, compromising on any efficiency. We try to build data types which will be useful for us for a data throughput of, let's say, petabytes, per minute kind of scenario. So we are still working on as an, part and parcel of Python development, Python platform development. But when you look at the overall data types, tuples are the most efficient list we have in Python. And when you basically crunch a bigger chunk of data, you can clearly understand why tuples are best. So let's try to understand what is tuples and how we can use these things in the best possible advantages of us. Right now, we are not going to start with really heavy amount of data, but at the end of the day, we are going to use this efficient throughput mechanism inbuilt in Python to make sure whatever we do will be using the optimum platform efficiency. And that's what we're going to start learning today. And then we'll move on to various statistical methods, understanding of statistical nomenclature, understanding of probability, understanding of how we implement solution, why we need those mean, median, average, and so on and so forth terminologies to implement in our solution. As a scientist, we are solution architect as well. So start thinking in that line rather than a typical, developer trying to solve a single problem. We are trying to build a larger set of solutions here. And the way we do, these solutions are used across industries as well. So many a time the solution which we build, nobody reveals it. You just release to the open system cadre. You might get some award, you might get some help in terms of improving the efficiencies and so on and so forth. And for that, we have really great source control called GitHub, and we're going to learn how to integrate GitHub as well, and how to release your code to Python, moderators as well, so that whatever your program you built can be released to a bigger subset, and you might get appreciation, you might get suggestions, you might be a kind of scientist in the group of scientists of Python development or Python solution development. There are various cadre in the Python development or Python scientific community to be precise, right? So let's start with understanding how we can make our development more efficient, so that we are near to the whatever facility Python platforms allows us to use, right? Let's start with the tuple. A tuple is a collection of Python objects separated by commas. And as we know, the lists are basically have to have a separate syntax as well as data types, right? So we've seen basic list, we have seen dictionary. Now we are seeing tuple. Tuple is also kind of the list, but still let's try to understand how these objects are useful for us and what makes them useful. Okay, in some ways, tuple is similar to list in terms of indexing, nested objects, repetition, but tuple is immutable, unlike the list which are mutable. So mutable is you are allowed to edit. Immutable is once you created, you don't normally mute it. So this is like kind of static database or creating constants, if you ask me, in comparison with others. Okay. So what's the help of creating constant and how they are going to help us, right? Lists are basically, object or arrays of objects or arrays of various variables. And if they are constants, what they use? Let's try to understand that. Let's try to understand why we use tuples. And tuples are the most used data types in Python development. A tuple is a collection of objects which is ordered and immutable. Ordered, the way you created it gets ordered. We'll see to that. The tuples are a sequence just like list. The difference between tuple and list, the tuple cannot be changed. Unlike list, tuples use parentheses, whereas list use square brackets. So this is the difference whenever you try to create any list with parenthesis, we are creating a tuple. So that will be by default immutable. Sets are another standard Python types that we also store values. We've seen set last times, right? The major difference is that sets, unlike list of or tuples, cannot have multiple occurrences. So tuples can have multiple occurrences. The major difference is that set, unlike other tuples, cannot have multiple occurrences of the same element and stored unordered value. So in tuples, we can have a really good ordered value stored. It's immutable, normally defined by parenthesis. Let's take a look at the video where we'll try to understand various different methods available to create tuples and to use tuples. Okay, let me start the video for you. Okay, it's called tuples, right? Give me a minute, please. Not TensorFlow. Okay. Give me a minute. Let me share this thing. So I have to go here. I have to stop share, and I have to. Okay, then. Okay. So that's why we use tuple. Is the efficient, as we say, and these are all infrastructure dependent facilities given in Python. These are available in Python. Even see, we have something like that. Okay, let's not go there. Let's stick to Python. So Python basically the platform created for efficiency, because as a data scientist, we consume lots and lots of memory. We required a solution which gives a throughput or processed large amount of data for a given time. And that's why we need, data types like tuples. Let's take a step further. Now let's try to understand the syntactical difference. These are really important because this can create many logical challenges whenever we do programming, right? All these sequence type, tuple, string list share much of the same syntax and functionality. Only the difference in curly braces. In the type of braces we use, tuples and strings are immutable, lists are mutable. The operations shown in these sections can be applied to all the sequence type. Most examples will just show the operation performed on one. So it's a step-by-step, explanation of these different type of list given here. So tuples are defined with a parenthesis, or what you can say, a brackets, right? Curved brackets. Then you have square brackets used for list or dictionaries. And then we have strings with a quote, right? You can use double quote, single quote, or multiple quote for comments and all those things. So this way, there's a hardly, little difference in creating these data types. So these are famous for interviewers to ask the question. He'll definitely ask at least one or two questions on tuples. And we'll see why tuples are so important whenever we go into the actual solution development. Access individual members of a tuple list strings using square bracket notation. Note that these are starts with 0. Okay, so first list of tuples is 0, then 1, and so on and so forth. The second item is tuple is 1. So whenever you access any particular item within your any of the list starts with 0. It's not 1. Okay, so as the example, see, try to play around with this. Okay, try using list, dictionary, tuples. Try to build a tuples with multiple lists and try to understand how the efficiency is being utilized as far as the platform goes. You can fill them. Means if your tuple tops the list of, let's say, 30 plus entities, you'll see the difference in access. You might create a timer to create an you can create a kind of program to display tuples or display the list, dictionary, and all the other things, and try to compare the differences. Okay, try to compare more than try to have more than 30-35 items in your list, and then you can understand the difference in efficiency. Okay, try to play around with the available methods within these different variables. Again, I have given a couple of type of examples for programming is, of course, we can have a negative indexing count as well. Okay, and so on and so forth. So this is really fun to use such type of things as far as slicing, dicing. So you can slice a subset, right? Try this thing on your own, so you'll understand much better rather than me reading these slides for you. I'm going to share this presentation with you. Okay, so no worries on that part. Omit the first next to make copy. You can have a list built out of a list. That's what we call slicing, or subsets, and so on and so forth. These are specifically like sets in math. If you done any probability or statistical function, the set, subset, and the different functionality we required in maths, right? So these are all these functions and compatibility with those elements, right? Let's go on to the operators now. Now, operators are basically whenever you assign two different variables. Okay, the colon is basically a copy for entire. Where am I? Okay, sorry. There's something missing here. I believe there should be. Okay, no problem. So these are again colon is a copy of entire sequence, or we use colon in our decision points, right? Decision nodes. Note the difference between these two lines. 12 equal to 11 hash. Both refer to one reference, and hash changing one effect on both. When you say L2 equal to L1 and L2 equal to L1, and then there's a colon. The independent copies, two references. We've seen this thing in a video last time, right? So how there's a single variable with a different name occupies same memory, and that's actually equal to kind of scenario. Here we are having two variables with a different memory, but their values are same. So there's a referencing by address, there's a referencing by value, and those kind of scenario. Okay, so these are basically making copies. Okay, now the operators. We have 7 operators in Python. There are arithmetic, relational, assignment, logical, membership, identity, and bitwise operators. Okay, these operators are really useful for your programming. As we learn operators in many other linguistic platforms, let's try to understand how these operators works in Python, and let's try to understand how to use these operators in the best possible scenario. Again, our Naveen Reddy is going to explain us, so give me a minute. I'll share that video with you. Stop. Let me share a complete screen. How do you share a complete screen? I don't know. Oh man, does that make complete screen shareable? What can you see on the screen?
The video.
Okay, the video is going on. Okay, let me start that. Okay, let me. When you start, go to your start. This thing, and you type IDLE and press enter. Right, it starts the basic Python command line interface. I just typed IDLE. I'll show you out. Give me a minute. Share screen, start share, and where's that thing? IDLE. Oh, come on. Ideally, this is what they call Windows shell, Windows Python shell. Could you see ideally on the top?
Yeah.
This starts the command line interface. Here, I can, start basically giving commands like TUP, Ravi, and how does tuple starts?
TUP.
No,
Just round brackets.
round bracket.
Oh, the square bracket.
Doesn't make any difference, because we are not specifying the type of variables. You need to really remember these things, because I can understand we are coming from Fortran, Java, C background, where I need to specify integer or string or whatnot, right? But here I'm just start creating a list. I'm just creating a simple, what you can say, a tuple. Let me go ahead with this. So I'll have not double one will be more than enough. Okay, 100, 200, 300. Okay, simple enough. It should work. I press enter. Cannot assign to expression. Okay. Sorry. How do you assign a value? Okay. I can't repeat this. Oh, I need to try. Okay, let me try. TUP, RAV, Ravi. How do you create tuple? Like this, and then come on. Okay. 1, 2, 3, 4, 5, 6. No. How do you start? How do you create tuple? Okay, let me go to my PPT and try to use to create a tuple. I can copy these things. It's like assignment to it. No. How do you create a tuple? Let's list. Okay, is this tuple? Okay, assign it, right? Okay, let me. Okay. Okay. No, again. What was that? What the hell is happening here? Like this. So let me try to delete this thing and this. With a list of numbers with this. Okay, let me try out here.
I think you cannot have a list in a tuple, but if it's not equal to will work if you don't have a list in a tuple.
Okay, so how do I do this tuple?
Tup Ravi equal to like you just give a string and a number is fine.
Okay,
And you can even give a tuple inside a tuple. If you just put 6, comma, some string, it should be fine.
But if I'm creating a tuple of number, it should work, right?
It is working for me. I don't know. Maybe there shouldn't be a space in the front.
Yeah. So that's a challenge I'm having here, I believe. No, again indent.
You shouldn't have a space.
It has a start, I believe. Let me try to delete that thing.
Even that's equal to.
Okay, it's already created. Oh man. So let me try out. I need to delete this. And I need to delete this.
Yeah, delete that space and try. Equal to.
Oh, yes. Oh man. It's a 1, and I'll say equal to. Again. What? Okay, let me try with Anaconda now. That's much easier. I'll go to Spider. Why it should work basically?
It's working for me though. I don't know.
This ideally, okay. This is basically I was trying to show you how that ideally shell works though, but still I don't know, something gone wrong with my shell. I believe that. Let me share the spider with you, where the spider is started. Wait, give me a minute. Okay, not this one, not this one. Okay, spider is started here. So I do have a, I'll start with new program, tup rav equal to, let's start with a numeric first. Let me create this. Oh, it's working here. Okay, so you're right. This is the same thing. No, cannot assign an operator.
It's working for me in idle. I don't know.
No, let me open. I have some files where I've used tuples. How do you open? Oh man, where is one? Okay, wait a minute. I'll go to schools, Python data science, practice, and I have a tuples here. T TensorFlow tuptry. This was working. I don't know why. Man, this is working. What I did differently. And there are some indentation here. I don't know. Okay. Could you see my screen? Sorry. Have I shared spider with you?
No.
No.
Oh, sorry. Extremely sorry. Oh man. Wait a minute. what you can see on, oh, come on. Oh. Right, what I'm sharing now, I don't know. If I go to Zoom, okay, start share and spider. Yes, here. See, this is working. Wherever I have these, all these, numbers with without indentation and all those things. So I believe, let's try with this, and I'll try to give some, string as well. Again, a comma. And let me try out these things. Oh, come on. I forgot these things here. And then I'll just copy these things. I'm just trying to be lazy here. And let me try to play around with this. So this also works, right? So it's a list of integers, strings, and then let's try with if you can have a part of list here. So I'll have these. Oh, come on. This. Okay, I'll use numbers first. 12. This, and this. Let me try if I can get this thing worked out. Yeah, that's also allowed. So you can use list in a tuple. You can have a string. You can have a integer in a tuple, right? Could you have a float? Let me try with the float. So plus this 3.543. Oh no, there's no space. Okay, let's try out with this if it works. So yes, I can use float as well. So, try to play around with this. And if you want to play around with the methods, functions, you can just say, is that right? Right? Yes. Come on, this thing. And then I'll paste dot or control space, right? Let me get the list of these things. I was supposed to be, oh man. Oh no, there's a, that's why it's not showing. Oh, again, what I'm doing. Okay, yeah. Enter first, and here I'm trying to find a. Yeah, show me the method names, right? Okay. Yes, now range, input, round. Wow, so many things. But these are internal variables, right? Yeah, these are for the written tuple for those whose items are same and in the same order of iterable items. Okay. Okay, great. No problem. Chalega. Okay, otherwise let's go to W3 and you can, see the different, I'm going to share this list of tuples. Where were the tuples? Okay. If you go to W3C, let me stop the share and start the share with these things. Okay, let me, I'll go to Zoom. And I'll start the share. I'll go here. Okay. So if you go to this link, I'll share this link with you as well. There are different, methods available: tuple, items, order, and chamber, and the properties they've given here. So there's a good amount of what you can say exercises are given here, right? Print type this tuple. This is what we did right now. These are the different type of tuples you can create. How to access tuples, update tuples. So, you can try all these exercises as well, whatever you want. And then you can get really well aligned with, actual tuple, right? So there's a del command, there's a, a remove command, then there's this add command, and so on and so forth. So please play around with these things and then you'll understand the tuple in more sense. Okay, let's try to understand the operators now. Pardon me for that. Let me share these things and we'll understand the operator part of it. Okay. So here, how come we are back on tuples? Okay, I was seeing the syntax for that, right? Okay. So yes, so there are total 7 types of operators, right? Like addition, subtraction, multiplication. I've tried to list down these operators here and a couple of examples. You can add a couple of lists as well. So lists get appended when you add it. You can add string. You can concatenate string. If you remove the middle space, is get concatenated. Then there are relational operator greater than, less than, equal to, and so on and so forth. And you can use multiple operators at the same time, not equal to, greater than, or equal to, or less than, or equal to, and so on. Okay, that's a error here, but okay. So these are the relational operators. Then we have assignment operators, right? We have floor, divide, and assign. So divide and assign, these are like, you can have multiple operations on a single line. So like exponential and assign, raised to power, modulus and assign, percentage, divide and assign, again, the division part of it, multiple and assign, this he just shown us, even, subtract and assign and add and assign. So these are, and single assign always. So these are all assignment operators and its combination. I have just collected them for our ease. You can keep it at a place where you can refer to whenever you want to, and then you can have a good reference material. I have also included some sort of examples here. So t equal to, I've created a list. 3 in t is false. There's no 3 in t, right? There's a 4 in t, 2. So you can perform arithmetic operators in the list, or relational operators in the list as well. And these are some of the example. Same thing like strings. We have tried the relational operators here, and then we can have a different type of loops where we use operators as well. Okay, these bitwise operators are a bit kind of again, we are going deep into the overall engineering mathematics here. We try to understand the gate operations, like this is a part of Boolean algebra, if you can remember. Who have not done engineering or who have not heard of Boolean algebra at this point? Anybody?
Me, I have not heard of it.
Okay, let me tell you. Well, Boolean algebra is basically an algebra with numbers 0 and 1 only. In our numeric system, we have 10 numbers, right? There are one.
So it's only binary.
Yes, it's a binary. But let me, cover the things with you. Maths is, again, a kind of playing with 10 images. That's what psychologists say. So when you say one number, there's a one single vertical line. 2, there's a 2 symbol we normally draw. There's a 3. But these are again images which are related to a numeric figure in our mind. In Boolean, we have 1 as in single 1. 0 is off. 1 is on. So 3 will be 1 0. Okay, 4 will be 1 1, and so on and so forth. So this is how we create Boolean algebra based on these things. And these overall, Boolean algebra use function like bitwise operators. So there's a bitwise and, bitwise or, bitwise right shift, bitwise left shift, and so on and so forth. Bitwise or, bitwise complement, first complements, and all those things. So this is a kind of needed whenever you do large mathematical comparison in terms of actual low-level programming. And I have given the Python operator precedence as well. This operator precedence basically important whenever you do larger calculations. There's a restrictions on compiler to execute priorities over others, right? Similarly, these are the priorities which are already assigned to the Python environment. So the start or multiplication or explanation sign get executed first. So when you say 2 raised to power 3 minus 3 raised to power 2, first it will actually solve 2 raised to power 3. That's cube of 2, that's 8. 3 raised to power 2, that's a square of 3, it's a 6. So when I'm trying to deduct 8 out, 6 out of 8, right? And that's how it gets executed. That's why this operation precedence is operator precedence is a kind of need, and this is a really good thought process. Basically, this is a really good what I can say preparation for larger calculation, because these larger calculation can create some logical errors which are really difficult to find. So that's why you can refer to this chart and try to understand how the precedence work in Python environment. Does that make sense, or I'm talking too technical?
No, it makes sense.
Okay, thank you. Thanks a lot. Or you can ask questions, or we can have this explanation or slide again played on whenever we do bigger programmings. Okay, we've seen the star as an operator. It's a multiplication operator, and this is how multiplication operator performs in a list. So when you say 1, 2, 3, it's a tuple multiplied by 3. It's 1, 2, 3, 1, 2, 3, 1, 2, 3. Same thing, when you say dictionary multiplied by 3, 1, 2, 3, 1, 2, 3, same thing. So this list get repeated. In string, same thing. It's get concatenated, 3 strings repeated. These are important whenever you do or play around with a larger data. And that's why I kept these things here. Okay. Then we have bitwise operator. Example of bitwise operator, we're going to see these things slowly, steadily. So operator on list equal to 1, 11, 3, 4, 5. List append A, not a method syntax. So when you append A with a numeric list, it's get appended, right? Insert 2i. So it's get inserted on the second position, 0, 1, 2. That's why the position number is important as far as lists are concerned. Okay, then we have extend method, list.extend 987. So this list got extended with 987. Okay, now let's try to understand extend and append as a difference. Extend takes argument. So whenever you add, like you pass argument to a method, right? So that's argument is basically passed as a composite variable here. And append is just you're appending the list. So whatever you have get just clubbed together at the end. So there's a bit of difference here. When you say append, it just get appended at the end. When you say extend, it's get added to the list as is another extension of the list. Could you see the difference on the screen? Here there are no braces. Here the complete list got appended as a variable. So now it's a compound list, compound dictionary, right? It's a simple dictionary. Wherever I've extended it as a number of values get added, not as a separate dictionary by itself. Could you understand what I'm trying to say here?
Yeah.
Yeah.
The difference between extend and append?
Yes.
Yeah. We are trying to learn the basics of operations, basics of assignments, frankly speaking. Again, the list have many methods like index, count, remove, reverse, sort. Some of them like index B, so index of first occurrence, right? So it'll be occurred at a number 1. Count of B, there are 2 B's. Remove B, it removed the first B, first occurrence in the list from the start. So if it's 0, then you get deleted as a 0, or whatnot. So this is the way this list operation works. I think I have jumbled up the sequence of my presentation, but let it be, no problem. And then we have reverse, we have sort, right? We've seen this thing, I believe. And then tuples. The comma, okay. The comma in tuple is a creation or an operator, not a parenthesis. So when you say 1 comma, is best get added as a 1 comma. So it's a kind of it'll treat it as a string basically, and it's get added. So that's how basically the Python works, because we don't have a separator, right? So separator can be really tricky in terms of Python. So we need to really be careful on these things. Okay, we had a look at tuples and set in Python basically. Same Naveen Reddy's video. Empty tuples have a special syntactic form. We don't normally create empty tuples. Empty tuples doesn't make anything. It's just a pointer. If you look at the overall, it just create a memory address direction. That's nothing. And as you can't update tuple, so creating an empty tuple, it's more of just a theory rather than a practical kind of scenario. We don't normally create empty tuples. So yes, list slower but more powerful than tuples. We can do many operations on list and very less operations on tuple. List can be modified. They are mutable. They have lots of handy operations and methods available. Tuples are immutable. You can't have tuples getting updated. So we have very fewer methods or features available to us. To convert between tuples and list, use list and tuple function. So there are these functions called list, li equal to list, and then I'm passing tuple in the list. But still it's a tuple going to the list. So that'll be immutable by itself. But I can have same tuple converted to list. So tuple equal to tuple list. So then tuple is converted to the list. So it will work as a list rather than a tuple. And then it can be mutable and all those things. This conversion we require because whatever we did, like in programming, right? If you want to update a tuple and write it again, then you can convert that tuple to the list. But all the previous operation as in tuple get efficiently executed. And then you can write whenever you want to update it, you can just convert it to a list and then write it to the database. This is what we do in normal memory buffer buffer type of solutions in Internet of Things or in Python everywhere basically. Okay, so you can convert these variables and this is a kind of really useful trick we use whenever we do some memory buffering kind of techniques, and we'll learn these things. We'll see in actual practical work. Okay, then there's a if else conditional statements. So we are using relational operators to specify our conditions, and I have just summarized the conditions here: equals, not equals, less than, and we've seen this in video as well, right? Just try to play around with if else. Try to play around with simple if statements, and you can get your normal program decision making done with the if and else statements in Python as well, like every other language. Then the while loop in Python, we have two primitive loop commands, while and for loops, like in C or Java. So while is basically till the condition last, and for is basically for so many iterations. So in normal C, here we can use the dictionary as well as to basically have these things in the loop till the list last. So that's a kind of advantages in Python. And we can have so many different string as in conditional statement or as in counter in for loops for them. Try out yourself and you'll understand. I'll also share the W3 school link as far as these loops are concerned. There are quite good number of examples. I've collected these examples from W3 schools only, so you can have a look at that, right? Then there's a break statement as well. So you can break it while I equal to I is less than 6, and then break when I is more except when I goes to equal to 6, and so on and so forth. So there's a break in the loop or exit from the loop in the executions, and it's like almost similar to other programming techniques we use. Next we'll learn about mutability here. So mutability is how mutability are important as far as Python goes. Mutability is when something is changeable. It has the ability to change. In Python, mutable means ability of an object to change their values. And these are often the objects that store a collection of data. So normally mutability applies to each and every variable, but they are more concerned in terms of mutability in the list, like dictionary, tuples, set and all, right? So mostly in Python, mutability relates to the lists. Name li still points out to the same memory reference when we are done. So list have to be basically updated. You can update list, you can append, add, and all those things, but still the start of the list remains same. It maintains memory address till you remove the list completely and recreate it, right? And let's talk about tuples then. Tuples are basically, you can't change a tuple, they are immutable. You can make a fresh tuple and assign its reference to previously used name. So when I say, I can have a composite tuples, the immutability, of tuples means they are faster than list, because as I told you, they just have the starting memory access, because there is no, maintenance as far as tuple goes. It's just a static constant. Treat it as an assignment of a constant. Let me play a video for you where we'll understand the mutability of tuples and why we say they are really efficient, right? So give me a minute. I'll share that video. Okay. So that's about overall about mutability, tuples. Please revise this thing. Please try to create your own tuple. Try to understand mutability in the details. Next time we are going to move on the overall APIs, and then we'll come back to these variables again wherever we use, whenever we use, and we'll try to understand in depth. Okay. Does anyone have any question for me at this moment?
No.
Okay. So please play around with it. Try to share your ideas. If you've done anything new, do share with the group so that we can learn together. As we know, we are deep diving into the depths of technicality now, and slowly, steadily, we'll go into the probability, we'll go into the statistical function, and so on and so forth. So please keep discussing among self. We have a group also created, so you can discuss it there as well. Don't feel like how can I do this, how can I ask this question and all. Please feel free to ask questions, and in some days we will basically reach a level where we can start thinking like a scientist, data scientist, and so on and so forth. I believe we have taken our baby steps so that we don't get confused or something like that. So even if you get confused, please do ask questions. Do visit these recordings, or do visit these videos from really great trainers. Even I keep learning from them again and again. And this is really good reference links I share going to share with you. So have a look at them, and let's meet day after tomorrow. Okay, and we'll start with actual API programming. Okay, thanks a lot for your time. Have a good night.
Good night.
Bye bye. Take care.